Hello, and welcome to my third tutorial on Murder. That is, the Murder Engine, a pixel art ECS game engine built on top of MonoGame. Last time, we created a system that allowed a character to move around, have 8 directional sprites, have a health system, so the player starts with 3 health. They take 1 damage from this white sheep enemy when they walk into it, which also has 1 health, and the player deals 1 damage to them, so they die on contact. We walk into it, we take 1 damage, our health is now 2, the enemy's dead. We walk into another, our health is now 1, that enemy's dead. We walk into the final enemy, and both of us are dead. The goal for this episode, we have a few things we're going to get quickly, such as a follow camera to our player. This is provided on the Murder Engine Discord, so I'd recommend you joining us. We're then going to learn how to perform actions over time, such as spawning enemies or bullets, by basically making a manager class. This would be very standard in something like Unity or other game engines where you have some kind of singleton manager, or you have a level manager or spawn manager, etc. So we're going to have that to create a basic system for spawning some enemies, and later on we can use the same sort of system for spawning bullets and whatever else we want. Finally, as part of all this, we're going to be creating a whole bunch of game asset categories that we can use within the editor to create the JSON data that the systems will then use. So first and foremost, let's get this player camera follow system just quickly out of the way. I'm going to go right to the systems, and I'm going to create a new system here. So we're going to add new item. We're going to call this the player camera follow system. Clean that up. And then I'm going to make this a iFixed update system. Now, iFixed update system, that's using bang.systems, and this is going to need a filter on it, so it knows, of course, what entities to filter for, as all systems do. And in this case, we can pretty safely ensure that anything that has a player component on it is a player, and that's the thing we want to follow. Now, if we were using player components in a way that allowed us to have multiple entities that we were controlling at the same time, then this wouldn't quite work. But because in our game, we know that the player component is in fact a unique component, it will only ever have one of these entities in existence, or should. Now we need to implement the iFixed update, which gives us the fixed update with the world context, or the context of the game that we're running in. Now we're going to just do a quick check here, sanity check, to ensure that the context has an entity. If it doesn't have an entity, we really just want to return. Now, the thing that we need to actually reference for our camera is called a camera 2D. This comes from the murdercore.graphics. We're going to call a local variable here just camera. And a tricky bit here is that if we look at the context, we can get the world, but the world does not actually contain a camera. The world that it gives us here is a bang.world, which doesn't really contain any of the implementation for sort of the murder 2D graphics rendering side of things. What we actually want to do is we want to cast this to a monoworld. Monoworld comes from the murder.core. And then once we cast it, we can actually get the camera and part out of it. There we go, camera 2D, monoworld camera. From the camera, of course, we want to set its position. And we can do this pretty easily by checking our context, getting the entity out of the context, precisely get the global transform here. And this will actually come up quite a bit later when we're dealing with the enemy's transforms. So it's important that we call get global transform, and then we can just get the vector2 value out of that, which gives us the point that this entity is considered to be at the global level. Now we could stop here. In fact, let's do a quick run and see what this actually gets us. We're going to have to add the system to our list of systems, so let's do that and test it out. So we're going to go into our features, and we kind of have to decide where we're going to place the camera follow system. I think on the character is a pretty good place to put it. However, it's also in a fixed update step, which means it's happening with the physics system. So we could put it under physics, or we can even put it on the render step since it is the camera and it's related to the camera systems. Let's try putting it here and seeing if we get any weird behavior. And if we do, we can try some of those other locations. Player camera follow system. Now, when we play our game, we can see that, hey, the camera is actually now moving in our world, and we can move our little character around. There are some downsides to the code that we wrote here, however. As you can see, our player is stuck in the top left corner of the camera as opposed to being nice and centered on screen. Additionally, our character is sort of filling up this square, and this tells us a few things. First of all, the origin of this sprite and this prefab is at 0, 0, and so is the camera. So the camera's position, its absolute point position, is the top left corner, as well as the sprite, it's the top left corner. So when both of these things overlap, we actually have the sprite on the screen, thankfully. This is a really good information to know now, because we're going to start with messing around with all sorts of things like bounds and the cameras, and we need to keep in mind that the top left of our game world, our game screen, our prefabs, our sprites, is the 0, 0 position. This is causing some issues at the moment, but there's some pretty easy ways we can fix it. We're going to actually modify the camera's position so that half of the camera's width and height in a new vector. And if we just did this, where we minus the camera's width and height, then we would actually end up with the player character at the bottom right corner, and they wouldn't be on screen at all because the entirety of the sprite would be off the bottom right corner. So we have a couple options. We can either take this vector and divide it by 2, or we can do something like use this half width of the camera, and then we only have to divide the height by 2. The half width is doing exactly what you think it's doing. It just does a calculation internally anyway. So perhaps it's more efficient to do the vector calculation all at once. I'm unsure. Either way, we do get a height and width divided by 2. Now with hot reload enabled, we can see that this code instantly started working, and our character is now sort of centered. The truth is that the top left corner of our player character sprite is the thing that is the center of the screen, the absolute middle position. And this doesn't really work for us. We want the character's midpoint to be in the center. We don't want the top left corner to be centered. And we can see that here when we go take a look at the prefab. We can see that this crossbar that represents the midpoint of the sprite, it's right at 0, 0. And the top left corner of our sprite is in fact also there, pretty much at 0, 0. There's a few ways we can fix this. We can add a child and move the agent sprite component into this child. That would be sufficient, because then we could control exactly the offset that the children is. Or we can set this up in a sprite by adding a slice and changing the origin. Or if we just weren't using an agent sprite component, or we're using a regular sprite component, say like the player has, we can control its offset precisely here. And we could say something like, well, set its offset to exactly half, and then it would be always exactly centered. We don't have that option with an agent sprite component, although perhaps we will in the future. So what we're probably going to do instead is to change this so that the A sprite is moved, because we don't really want to mess around with the children here, at least not yet. And like I said, it is one option to fix this. However, to keep things simple, let's do this in ASprite. I'm not very familiar with ASprite, and this helps me learn more about pixel art and ASprite in general. So here we have our ASprite Shipsu, and all we really need to do here is go to the slice tool, which is under the move tool. They share the same little bar here. So we select the slice tool, and then we're just going to take the entirety of our image from top left to bottom right, and we're going to create a slice. So by double clicking on that center area, we get this little slice properties menu, and we're going to call this the player slice. Really, this doesn't matter what we call it. We can separate these slices to organize ourselves in some way. What really matters for the purposes of what we're trying to fix is this pivot value. So we do need to check this box to enable it, and then we're going to set the pivot to be exactly half of our image size. So this is a 32 by 32 image, and therefore our pivot needs to be at 16 by 16. Now we can save that back into our Shipsu character, And we will need to reload the atlas. We will notice that our slice is not applied. And that's fine. We'll actually see that there's two Sheepsu assets here now. So when we reload the editor, we can see that the sheep is gone, it's missing. And that's because the original asset that we had selected was unsliced, which was a different GUID than the sliced asset. So now we just select the sliced asset. That's the one we're going to save. And now it is perfectly at the origin point. Our collider here is notably not at the origin point, handily noted by this X. It's off to the side because this is how we tried to set it up before. We need to fix this collider. Now we can basically do it the same way we fixed it before. We can just change this to a sprite that most easily shows us what the collider's outline is going to be, and then just move it into place. I want a point of reference here to ensure that my sprite is actually animating with the hitbox exactly as I want it to. So with this tail, I can see that it's half the tail is going out of the collider and half of it's staying in per frame. So I can use that for a reference when I flip it to look left. If it's the same on this side, then yes, this hitbox is perfectly centered, and visually, yeah, it looks pretty much centered. Now the player, which is an instance of the character base, it's not going to have those changes applied. If I try to discard the changes on the player, it actually just fixes itself because it knows that the current state of the player that I had open is not the state that I wanted it to be in. The state I want it to be in is the state from the character base JSON. Now that's not going to work every time, so you may have to change some things, especially if you've already changed it. For example, if we look at the enemy component, if I discard changes from the enemy component, the collider gets adjusted, but the sprite does not. Of course, because the sprite is a different sprite asset, so I need to actually go into a sprite and apply the slicing here again. This also means that I need to restart the editor, otherwise I'm going to end up with two different slices. Exactly, so now I'm just going to restart my editor. I can see that the quote-unquote bad image has been now removed, and I can add in the good one. And I don't have to do anything here anymore because it's already set up. So both my player and my enemy now have correct sprites and colliders. When I run my game, I can see that the player is perfectly centered on the screen. That about does it for the quick setup of the player camera follow system. If you want a different sort of camera movement, you could do something like a vector2.lerp, and by lerping the current position of the camera to the position that you want it to be by some amount, you'll get an interesting lerp value. So let's actually take this value and say end camera position. So we want to take the camera's position and our end camera position, and then we can lerp it by some amount. If we have a fixed value here, say 0.2, then it will get 20% closer to the player. Now, when we play, it may not be very noticeable because this number 0.2 is quite high, but there is now like a delay when the camera moves compared to when the player moves. To make this much more dramatic and noticeable, we can do something like set this to game from the murder namespace, fixed delta time. So this will lerp it by a fixed delta time. This will be an extremely small number. So the camera is not going to catch up with the player very much at all. So we have to go pretty far away from the camera before it will start to catch up because it's a multiple. And we can then play with that value even more to sort of figure out exactly where the player should be. Eventually, this number will return the camera pretty much perfectly to center. As we get closer and closer to center, you'll notice that the pixel perfect values will cause the camera to seemingly jitter, but that's sort of intentional. Murder Engine does have a way to make this camera not pixel perfect if you so prefer. However, it's best to sort of just avoid doing this kind of very, very slow positional updates. It's not really the intention of a pixel art system to have such smooth movement, after all. For now, I like the look and feel of a perfectly fixed camera, so I'm going to go back to how I had it here. Okay, with that little detour out of the way, we're now ready to work on the more advanced systems of actually spawning in enemies. To do this, we're going to use a state machine. As I mentioned before, state machines is one way to create a manager-like system, and you can use state machines for all sorts of purposes. The way we're going to be using it is not quite like a state machine's by name. A definition of a state machine would be something that is following specific states at a time. Have it like a manager, where it's going to track when the enemy should spawn, how many should spawn, it's going to pull from data, and it's not going to manage the enemies, it's really just managing the spawn system itself. Now, there's a few things that go along with this. We're actually going to be needing to make the enemy spawn manager. We're going to need to make a data asset, a spawn event, and a spawn manager component. The spawn manager component is basically the component that references the actual spawn manager in the world, the state machine in the world. And if you've taken a look through the game system already, you'll notice that the main menu, which comes with the Hello project, it has a state machine component, main menu state machine. This main menu state machine has a field here which filters for all the scene types or the world types in our game, and so we can choose either menu or hello world. And so when the player presses play, it will load into this world. This field here is a JSON property field that allows us to filter based on the type of information, say worlds, that exists in our assets. And this is pretty much exactly how we're going to set up our enemy spawn manager. But instead of building out UI and having it react to UI, we're going to just do it based on the data item that we're going to create through the enemy spawn data asset and the enemy spawn event, which is what I'm calling the data type that we're going to manage. Enough preamble, let's get into it by opening the state machines and adding a new state machine. And I said we're going to call it enemy spawn manager. We could call it enemy state machine, etc., but really what it is a spawn manager, and I prefer to use that kind of naming. This is going to be of type state machine from bang.statemachines. Clean that up. And then the very first thing that we want to create is that private read-only GUID. And this is going to be an enemy spawn data ID. It's going to default to this GUID.empty. Now this is going to have a JSON property, but before we can actually set the JSON property, it's going to be a game asset, but of what? It's going to be a game asset of a new type that we're going to create. There's no folder already dedicated to these types of assets, so we can just make a new one in the Hello Murder directory. And, we're going to add a folder. Because I have the project running, I can't just rename things on the fly. I do need to stop the debugging process. I'm just going to create a new folder. I'm going to call it assets. And if we want to use the hot reload, we can hot reload now again. But for now, we're just going to add the new item. We're going to call it the enemy spawner data asset. And this is going to be of type game asset, so we can then filter for it. The game will then also know that it is something that is considered a game asset, and we can pull it up in a few key areas that we'll see in just a bit. My first few variables here, I want to set up an icon so it's easy to see. This icon could be an ASCII character or something similar. I'm just going to set it as a letter. I'm going to tell it that it will go inside a new editor folder. And the hashtag here for the first letter is the icon and then the name. So if I put enemy types, it would be enemy types, and that would look weird. So it's just the hashtag enemy types so that it will show up correctly. Then I have a public override vector4 for my color. Again, this stuff is more or less optional, just so that we can easily differentiate this stuff. This is going to be a new vector4. And because it's the enemies, let's make it nice and red. So it would be RGB, so 1F, 0F, 0F, and 1F. The fourth value is probably the alpha value. Now I want the actual information that this spawn data asset is going to contain. There's a few ways I could do this. I could just set, say, an ID, a GUID for the enemy prefab that I want to spawn, or I can set some additional information that I can then use in the spawner. And I think that's the way I want to go for this. So I'm going to set the public float starting spawn delay. And this starting spawn delay will be how long it is between spawn time. How long to wait between spawns. This value never changes, but runtime could. Store it locally. If we wanted the spawn delay to decrease so that more enemies spawn faster, or with less time between them, then we should do that inside the run of our enemy spawn manager. And I'll show you how to do that in a moment. We need to know what we're going to spawn. So I'm going to create an immutable array. And the immutable array is going to be of a certain data type. So this could be an array of GUIDs, the enemies that we're going to spawn. Or, again, I could set another data layer here by creating an additional class that's going to store the information related to the type of enemy I want to spawn. This is going to be our enemy spawn event. In our core folder, because this is a core element of our game, although we could really put it anywhere, I'm going to create a new class. It's actually going to be a struct, and we're going to call it enemy spawn event. This is the actual struct containing the spawn event for a particular wave or group, or in this case, a particular enemy type, if you will. There's a few things I can put in here. For example, I could put the speed that the enemy needs to start as. Now, I could bake this right into the prefab and say that an enemy has a impulse of 5, or an agent has an impulse of 5. But by doing it this way, I can reuse the same prefab again and again and just change the value that's in this data event in order to have it be modifiable. Now, I actually need the read-only tag here. Then I'm going to have a public read-only bool. Should this chase the player? Now, we're going to set this up later. We're going to create a move to player system or chase player system. And this flag will allow us to say if this spawn or this wave or this type of enemy actually tracks the player or not. Again, in this case, I'm sort of organizing them by enemy type as opposed to waves. So this represents a single enemy type within the larger context. And then I need to actually know what is the enemy I'm going to spawn. What do they look like? What is their prefab? So I'm going to create a game asset ID attribute for a public read-only GUID, and I'm going to call this the prefab to spawn. I need to bring in a prefab asset from murder.assets. Finally, I'm going to have a spawn time start field. This represents how long into the level we wait before starting to spawn this enemy. So at a spawn time of 0, that enemy should start spawning right away as soon as the game starts. At a spawn time of 10, then they should wait 10 seconds for the game to have progressed to the point where 10 seconds have passed, and this enemy is then a valid enemy to spawn. Now, I do finally need a public constructor, just called enemy spawn event, and it basically just needs to be an empty constructor, just to make the compiler happy. Back inside the enemy spawner data asset, we're now ready to have this immutable array of enemy spawn events. So these are the enemy spawns that are contained within this enemy spawner data. We need to initialize this as an empty array, and then we can add elements to this in the game hierarchy. This list of enemy spawns, again, this is going to be a fixed list in the order that we want them to appear in this list. However, because we have already within the enemy spawn event, we've set up the time to spawn. This is going to be the thing that dictates when any particular enemy in this list will spawn. It lets this system be a little bit more flexible, and the order in which I put them in this list won't matter. It is more numbers to change if I want to change everything in one sweep, but I digress. Finally, back up the stack into the enemy spawn manager. In the enemy spawn manager, I need to track a few things. For example, I want to track what the current enemy will be. So this is just going to be an index of which enemy from the enemy list am I going to spawn next. Then I'm going to create an immutable array, which is the enemy spawn events array. I don't want to create a new list here. I can just use the built-in empty to initialize an empty array. And rather than calling it enemy spawn events, I really just want to call it possible enemy sets or possible enemies. So this is the list of all the possible enemies that we can spawn in. We have access to the data class. What I can also do here optionally is create a second immutable array, which is the shuffled list. Then I can take the list of possible enemies, apply some shuffling logic to them to change around the position of where those enemies are with some basic array manipulation, randomization. And then I'll always have the list of possible enemies in the order in which the enemy spawn event is dictating. What I realized here is I didn't actually finish out what I was doing with the JSON property. Let's finish out what we were doing with the JSON property here, because that's really, really important. We are trying to filter by the asset ID of the type enemy spawner data asset. There we go. So now, just like we saw before, this enemy spawner data ID will only be a list of valid enemy spawner data assets that we have created in the project, and it won't show us every asset. We can create these two lists. You could have it as one if you were fine with that. And then I'm ready to start constructing the enemy spawn manager. So enemy spawn manager. And we want to construct this with a GUID of the enemy spawn data. Doing this here is not really going to have an effect because we're not spawning this dynamically by passing it an enemy spawn data. This enemy spawn data would get set into the class variable for the enemy spawn data. This would work if we were creating the enemy spawn manager dynamically. Say the player has picked a level and we know the information related to that level, and we get past some information to spawn the level in, we load the level, we set everything up, then we need to set up the enemy spawn manager, so we tell the enemy spawn manager, here's the GUID of the enemy spawner data asset that this level is going to set up. Now, we don't have all that other support, and it would be quite a bit to set up. I do want to do that eventually. I definitely do. I'm going to skip that for this video for now because it's already quite a lot to do. So we're going to just worry about setting this in the editor. But it's set up so that if we do spawn an enemy spawner manager dynamically, that's a mouthful, then we can pass it a GUID and it can set itself with that specific enemy spawner data asset up when it loads the world or scene. In the case that we do not have an enemy spawn manager with a ready enemy spawn data ID, we're then going to rely on the enemy spawn data ID being set as the JSON property, say from within an existing world, just like the menu system is set up. In that case, we just need a default constructor. And in both cases of the default constructor or the custom constructor, we're going to run a private enumerator with something called wait. Wait is from bang.statemachines, and that is the yield operation that this enumerator is going to leverage. The enumerator that's running is basically the level, the actual level that we're playing in. While this thing is alive, we can run a game loop here. And this is where we start to get into basically the idea of a state machine, because we're not a system where we're doing an update every frame or a fixed update. We're more like a coroutine where we can kick off when we get spawned in. So we can do something called state, set the state by this. And if we were doing an actual quote unquote state machine, then we could have several different states and several different ways to set the state and transfer between states. And it would run whatever operation that we give it. The first thing we should do as soon as we set this state, we should tell the game that this spawn manager is an entity. What we need to do, create a component. This component is going to be called the enemy spawn manager component. We only ever want one manager because this is sort of a singleton pattern. So we're going to use this unique field, which is in bang.components. And we can also tell it that we only ever expect this component to be set during the runtime because we're going to spawn it as soon as the state machine loads. This isn't a class, this is a read-only struct because it's a component and it inherits from the iComponent. Okay, not so bad. Back to our spawn manager. State machines have a reference to their own entity, so we can do entity.set enemy spawn manager. Set enemy, there we go. So bang.entities set enemy spawn manager. Now we want to fetch this data. Create a local reference to the enemy spawner data asset. It's called spawner data. We're going to get it from game.data, and this game is from using murder. So game.data.getAsset. And it's a very specific asset, which is the enemy spawner data asset. Which enemy spawner data asset? I'm so glad you asked. The enemy spawn data ID. So this will get this specific asset from the assets directory, and it knows which GUID it is because we're going to tell it. I'm going to quickly yield break here, just so I can show you what's going on and we can start setting some of this information up. So in our murder editor, we can create a new asset. It says, what's the asset type? We're going to find our enemy spawner data asset. Then we're going to give it a name. We're going to call it enemy lamb spawn data. It creates a new enemy lamb spawn data. And notice over here are enemy types with the icon of E. So all these other ones have custom ASCII icons. We're just using a letter here, so we always know E for enemy types. And then within the enemy types dropdown, there's enemy lamb spawn data. So now this could have many different spawn data. We can have level 1 spawn data, level 2 spawn data. We can change kind of how this is working. But basically, we now have our fields here that we put in our enemy spawner data asset. So we have our starting spawn delay, default to 1 second, so we can change that if we want. And now we can add the enemy spawns. And as you can see, this just adds this big list of enemy spawns. We have the enemy impulse, we have our boolean to chase the player, and we have our prefab to spawn. So we're going to set this as the enemy. And then we have our spawn time start. So this list of this prefabs to spawn, these are only the valid prefabs that we have created. Now it is all of them. So There may be another way to, say, better organize this so that it's only a specific subset of prefabs if you'd like. But since they're all of the prefab variety, they're all the same. If we had derived a prefab class, made our own prefab class, yeah, we could do a whole sorts of things there. We can set them all up with the same thing. And then I can change their impulse. I can change their start time delay. So this one starts spawning after, say, 3 seconds, just for demo's sake. And this one starts spawning after 5 seconds. So we should never see this enemy, or sorry, we should never see the third enemy before we see the second enemy, based on the way I'm going to set this up in a moment. However, all three are the same prefabs, so it's going to be very hard to differentiate them because I'm not coloring them dynamically or changing some sprite on them dynamically. So maybe we can just quickly do this so that our enemy has a bit more dynamicism to it. I'll probably just speed through the next little part of this video because all I'm going to be doing is painting assets and creating new prefabs. So see you in a bit. One thing I could do is, say, bump the player's health to, let's say 10. That's probably sufficient. Now, in our spawn data, we can change these prefabs to reference the different prefab varieties. Red's a pretty intense color. Let's spawn blue as the second and red as the last one. So it should go white, then 3 seconds later blue, and 5 seconds later red should be added to the enemy spawn pool. The way we're setting it up, we will spawn only one enemy at a time, and we're going to make it so that we go through the entire list of possible enemies before reshuffling the list and randomizing it again. We'll remove our yield break. First, let's just do a sanity check to make sure that we've actually set up the data asset correctly. So the spawner data asset, we could check to see that it's not null. I think the get asset is going to throw an error if it is null. So we can just immediately check the enemy spawns. This would also throw an error too if it is a null reference exception. And we're just going to see if it has 0. If it is exactly 0, then we got an empty asset. We got something, we got the enemy spawns correctly, but the list was empty of enemy spawns. So we didn't set it up correctly, and therefore we should break. We can also make use of our game logger here, just to remind ourselves there were no enemies in the spawn list. Now, something I played around with when I was working on this, the very first frame, we're actually going to run into an issue where our first enemy that we spawn is always going to spawn in the same place because the random generator is not being seeded. The simple solution at the moment is just to wait until the next frame. So technically our enemy doesn't spawn on the first frame. They'll spawn on the second frame that it's available. And we can just do wait.next frame like that. It's not even a function. Very simple. Now we're going to set up our actual spawn timer mechanic. Our current spawn delay is our spawner data starting spawn delays. So our current spawn delay is the starting spawn delay. So if we want to modify this current spawn delay, here is where we could do it. Modify this value as opposed to modifying the data asset value, which would be bad. And now this is something that I don't like doing, a while true loop. Personally, I don't like while true loops. So we should probably set this up like while player is alive or something. I will say, we will add it. I will try to add more like game logic. But for now, we need to just set up some of these basic mechanics and get a game to play. Possible enemies. Dot length. Spawner data asset dot length. So what we want to do here is check the spawn list. See if there is a valid spawn to add to the current list. So let's check our possible enemies and see if there's an enemy within our data asset that we don't yet have. Otherwise, if we have all the possible enemies, it's just going to skip all the rest of this logic. If it does, then we need to run a for loop because I know that each enemy in the possible enemies.length is ordered by their spawn time. I can set my I to be the number of enemies that we currently have. So if we have our first enemy that spawns at 0, that's in our list, then we know that enemies 2 and 3 will spawn later. Now, there's nothing that we've set up here. For example, in this enemy spawns list, we're not sorting this by the spawn time start, technically. So this could throw a problem. Potentially bad if enemy spawns is not sorted by spawn time start. We're going to assume that it is, though, because we know that we set it up. And so we're going to see that the spawner data dot enemy spawns dot length, and we're going to increase our index here. Now we want to see if the time, which is our current time, if the time is greater than the spawner data dot enemy spawn dot I dot spawn time, then we're going to add it to the. In theory here, because we're doing this shortcut of if possible enemies.length, since we know that these things are in order, we don't necessarily need to worry about which enemy we're looking at the spawn time, because we know that they spawn in order. So the only thing that actually matters is the next enemy. And if that thing spawns, then what is the next enemy after that? What we may want to do efficiency, I think else break. If the next enemy to spawn, we haven't met that time criteria yet, then there's no way the enemy after that is ready to spawn. So the list of possible enemies, we want to add to that. It has an add function which returns a copy of itself with the new data in it. So we're going to say enemy spawns I. So add this new enemy type that you don't yet have into your array. Shuffled enemies. We're going to create this as a shuffled enemy. We're going to shuffle the list, and the current possible enemy, we're back to 0 so that we can start from the beginning of the shuffled list. Now, this shuffled enemies, we actually want to basically shuffle this list, and we also don't want to shuffle twice. Like, we only need to shuffle once at the end of this loop. So what we could do is, I don't know, bool added something equals false, and then add something equals true, and then if added something, do the shuffle enemy shuffle. This is technically more efficient than potentially shuffling twice. Okay, how are we going to shuffle? Well, I pretty much just yoinked the example from the Loom Dare game, and we're going to use that. So we're going to quickly add that in. We're going to take an immutable array, which is our type of enemy spawner data events, actually, enemy spawn events, and then we're going to shuffle it. So we're returning a immutable array of enemy spawn events, just like the add function does. And we're taking an array of enemy spawn events, which is our array. We're converting this to a list, which I'm not a huge fan of, but it's one kind of quick way to get this done. I think there's probably better ways. But again, we just want something up and running and working. We need to make a new list from the existing array that we are passing it. Then we're going to shuffle it using something called the Fisher-Yates algorithm, which is, you know, it's a fine algorithm. I don't know if I'm optimizing it because I'm taking a second pass at it. Yes, but if I'm doing my first pass, I just want it to work. I believe with the Fisher-Yates algorithm, we actually want to do this backwards. So we're going to do n-1 and then I0 and then I minus minus, which may be easier for things to sort of manage. Now we're selecting a random game.random.next. So this is why we need to wait a frame so that this random gets seeded. We might be able to seed it randomly ourselves right away when the shuffle happens. But since it's getting seeded for us, there's no reason to us double up on that if we just need to wait a frame. So we're going to create this temp. We're going to grab the item from the list. We can then swap the list over, and this actually needs to be the other way. This needs to be I, this needs to be J, and this needs to be I. Okay, there we go. And then we need to put back the item in this other position so it's randomized. Then all we need to do is return this immutable array We're going to use the create range function to then pass it that list. So then we can call our shuffle function here, and we can shuffle the possible enemies like that. If the current possible enemy is greater than the shuffled enemies list length, then we're going to reset this value, possible enemy 0, and shuffled enemies will shuffle. Possible enemies. So now the next thing we can do is actually figure out how to spawn this entity. That's the whole goal of this thing, is spawning waves of enemies. So let's pull the data. Let's create a local variable of the enemy spawn event data. Current spawn equals the spawn data asset dot enemy spawns with an index of the current possible enemy. We're going to create a function here, which is going to spawn the entities. What we want to take in is the GUID of the prefab spawn. And we could just pass the entire enemy spawn event function in here, but we actually don't need all of that information. We just need the prefab to spawn. We need the enemy's impulse so that we can set its speed. We need the value that if it chases the player or not, so we can add a component if that's the case. And I think that's it. We just need those 3 values. So let's call our function spawn entity and give it the current spawn dot prefab to spawn, the current spawn dot enemy impulse. I guess it could just call it impulse instead of enemy impulse, and then finally this chase player boolean. And now we are going to actually spawn our entity. So we need to get the prefab from the data.getPrefab. So similar how we get the asset, there's another function to get the prefab, and we pass it the ID of the prefab to spawn, the GUID. So now we have the prefab. We need an instance of this prefab that's spawned into the world. So we are going to have an entity that's created with prefab.create and fetch. So it's really handy that the prefabs have this thing built into it called create and fetch. And then we need to tell it what world to spawn this entity in. We can do the trick we did before. So our world equals mono world. We can now figure out where in the world we want to set it. So what I've done, or what I've decided to do, is I want the position to be starting as vector 0, and then basically the bounds that I want to use as reference. So where I'm going to put the spawn point, where I'm going to spawn the enemy in, is going to be the world.camera.bounds. Doing it this way will ensure the spawn location is going to be where the camera bounds are, and then we can spawn the enemies right outside the bounds or right inside the bounds. This bounds we could replace with anything else. For the sake of this demo, I like to do it on the bounds because then as the player is moving around, the spawn point is constantly going to be shifting based on the character's position, the camera's position, and the relative difference between. And then if I want to spawn the enemies always off screen so they're not visible, I can do that by making sure they spawn outside the bounds. Now, I need to modify the position. So position starting at the top left of the bounds. The top left of the bounds is the 0, 0 position, basically. Now I can modify the Y. We could either set this inside the enemy spawn event. Let's do it now. Let's set a public read-only float. And let's say spawn Y offset. And let's do a public read-only float spawn X offset. All the sprites that we're using for this game are 32 by 32, so we can assume that the offsets are 60 by 16. We need to pass this value, set it up here, float X offset, float Y offset, and then we would just do current spawn dot and current spawn dot spawn Y offset like that. So position dot X equals X offset. Now, if I just do it the XY offset, then it's going to mean that They will spawn always at the top left corner and always fully on screen. We also need to take a quick break from code here because we need to go into our world and ensure that this state machine is actually going to exist in our world and run in our world. So we're going to add a new entity. It's going to be an empty entity. Obviously, it doesn't have a name because it's empty. We're going to give it a name. We're going to call it our enemy spawn manager. Then we need to give it a component. If I put enemy spawn manager here, I do get it. But when I search for enemy spawn manager and I add it, it does get added as a state machine component. And I have this drop down with enemy spawn data ID. I open this, there's only one entry because there's only one thing in enemy types, which is our enemy lamb spawn data. And I can save this, and now let's test it out. So this is what I was saying earlier about while true loops, we never move on to the next frame. We need that yield break that's here somewhere, or yield return next frame. We're not actually waiting here at all. So before we kind of fix up our spawn code, let's fix up our loop code, ensuring that this actually waits the amount of time it's supposed to wait. After our spawn entity runs, so we assume that that entity has spawned, just do a quick check here. If the shuffled enemies list length or array length is greater than 1, so there's more than one enemy to worry about spawning, then we need to increment the current possible enemy to be that next number. Then the spawn timer is what we basically are tracking here. So the time is increased by the current spawn delay. And we're not like yield waiting for the next frame. We can actually just fully yield return wait for seconds. And what's the seconds? Well, it's the current spawn delay. However long we need to wait, we're going to wait until then, and then we'll come back into this loop and do all our checks and spawn our entities. We shouldn't just get stuck on the first frame. There we go. I'm not sure why they're disappearing. Perhaps because when it spawns another sheep on top of a sheep, they kill each other and disappear. That's probably why that's happening. As we move, the spawn point of these sheep should be following us. Oh, I know. I'm not actually setting the position. To do that, we can do entity.set global position as the position. We can do some other things while we're here, like setting the agent. Set agent with the enemy impulse that were given. And its acceleration and speed is basically the same thing. And I can set, if I want these things to have friction or not. In this case, I don't have anything that's driving their speed every frame. And then if they are chasing the player, then we can actually create something else. Create a move to player component. And we'll do that in a second. So let's see if now setting the position, they will actually follow the camera. There we go. So we can see every time it spawns, it's spawning in. If a second one spawns on top, it kills each other because we're not filtering these collisions in any way. We could filter them so that they only collide with the player and they just pass through each other. That's an option within our triggers, actually, to say that it only gets triggered by the player. So there's a few things we can do here. But anyway, we're pretty close to kind of getting this spawning sorted. Now we just need to go from the top left corner to, well, wherever we want. In this case, we want to handle it with the bounds. For a different approach, let's try randomly selecting what corner this sheep is going to start their offset at. And to do that, I'm just going to do a random dot next between 0 and 4, non-inclusive. So it'll be 0, 1, 2, or 3. And then I can make my bounds again. And now one way I've done this in the past is just by having a switch statement. There are probably other ways to do this, and that's fine if it works. This will be the top edge. So position equals bounds.top left. So basically what we were doing earlier. And then we can set the position X to be plus a random float. Float between 0 and bounds.width. And then we'll break from that case. And we'll just do this a few more times. So this will be the left edge. The reason I'm doing top left here again is because, again, this is 0, 0. So I can then do position.y plus equals, getting that random float dot height, break. Then case 2, this will be our bottom edge, which we do position equals bounds dot bottom left, and bottom left is 0 plus height, 0x and then max height. So from 0x we can do position dot x plus equals a random width, break, and finally case 3, our right edge, and we're going to do position equals. For here, I think the top right actually makes a bit more sense. Yeah, because top right is 0y. Now I don't currently have the XY offsets in use here, so we could do that by saying this is the top edge, therefore the position dot y should actually be less than, because the top edge, we don't want it, if we don't want it to be on screen, it needs to be minus so that it's above the screen. And for the bottom, it would be position.y plus equals y offset, so that it's below the bottom edge of the screen. For the left edge, it's position.x equals x offset. And then for the right edge, it's position.x plus equals x offset. Let's see where we get with this. Yeah, so we're moving around. The enemies are spawning all around us. We can't see them though. So just to test that this is working, we can actually reverse the offset so that they always spawn on screen. Okay, now if we sit still, all our enemies should spawn on screen. They should spawn at an edge. Ignore this guy, we moved. If a sheep overlaps another sheep when they spawn in, then they kill each other. One thing to just sort of stop that from happening from now, we can do, we can interact on collision component, and we can do player only. We should be able to do that for all of the enemies, and it should no longer let them collide with each other. So let's see if we get some overlaps here. Yep, that's an overlap. That's an overlap. Oh yeah, okay, so that would work. Now if we walk into the boom, 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 we take damage, we have like 10 health. We're super tanky sheep. Oh, we're dead. The next things that we sort of want to do here is we basically have all these steps done. We want a move to player component and a move to player system, and I pretty much consider this complete. So the move to player component is just going to be a component we slap on. The move to player system, it'll be slightly more involved, but no more involved than the player camera follow system, I would say. So to start off, we're going to make a new component. move to player component. It's a struct component. Read only struct, that's right. Back in our spawn manager, right where we spawn the entity, we can now add entity.set move to player. We're going to create a new system, make a new item. We're going to call it move to player system. Is going to be a ifixed update if, there we go, we're going to implement the interface, and we also need to implement the attribute here, which is the filter. What are we looking for? Well, we are looking for the move to player component, and we want to ensure that anything with a move to player component also has an agent component, because the way we're going to move these is via an agent. To start off, let's make sure that the player is valid. We don't want to move towards a player that doesn't exist, and we can't because we won't be able to get the information from it. So we're going to call try get unique entity, and we're going to get the player component, or we're going to tell it that it must have the player component. If it doesn't exist, then we're going to be given a null value, in which case we'll just return. Now, let's get the position as long as that player was not null. So player, and I say get position, but we're actually going to do the safer get global transform to vector2. And now we're going to do the system loop, which is for each entity in context.entities. We could do the same thing here, which is that if context.entities has any entity, not have any entity, then return. Now our entity position is going to be its current position. Then we want to calculate the direction to the player, which is just some simple math here. Get the player's position minus that by our entity position. And then we want to normalize that into a vector. This needs to be actually a function. There we go. So now we actually get a vector2. And now we can set the impulse. We need to use bank.entities dot set agent impulse and give it a direction to the player. Let's see what this does. We're going to have to implement the system. We also need to make sure that we actually set some of these entities to be chasing the player. So let's set them all for now. That way they're not just sitting there. Ideally, we could put this under physics because we are setting the agent impulse. At the same time, we're basically doing the same thing that the player input system is doing, which is setting the agent impulse, and the physics system is the thing that's moving it with the agent impulse and checking the collision, all that. So let's try putting it here. Move to player system. Check it out. So right now, none of our entities are set to follow us. I did have something backwards here. Oh my goodness, they're coming after me. Oh my goodness, they're coming after me. We've hit possibly another issue. So these entities are colliding, and if we look here, we could see this is looking for a collider component, and this entity, it doesn't have the collision component during the collision event. So it's being killed, its collision component is being cleaned up, and then it's trying to send a message by checking the collision component. It's already gone. So we need to actually update one of our old code from the previous tutorial video to make sure that this doesn't happen. We try to kill and clean up this entity. However, right here, we remove the collider immediately. Doing this, removing the collider immediately, means that if on the same frame, it's immediately going to remove the collider, and immediately the next collision event, like multiple contacts all happening on the same frame, is going to trigger another collision event. It's going to be looking for a collider to process the collision event, and there's no collider. It's gone. One simple fix to this is instead of removing the collider immediately, because we're going to kill the entity, we're calling destroy on it in just a second. We're going to call entity.setCollider, and then we're going to get the collider and set its layer. And we're going to set the layer to 0. So ignore this collider. Anything else that's going to check to see if it's a trigger, if it's an actor, it's not going to have that because we're setting the layer to null. If we look in here, saying sets the layer according to the collision layer space. So if we set this value to 0, it has no collider. Otherwise, it works off of a flag system where we can check all or none of these. Let's see if that's enough, or if destroying it on the same frame is going to cause a problem, because I think destroy just flags it for cleanup, not destroys it immediately. So let's see. We'll know if it didn't work if I somehow start having issues. Okay, so we did have some issues there. I think I know why the second set of issues happening. Obviously, you can see our little sheep skating around. Our player did die. However, you'll notice that our enemies here are freaking out. They're coming at us. There's a few reasons for this. I think the primary reason is setting our speed override here. So rather than setting the speed override, we probably want to do this a little bit differently. Let's set the agent impulse. So kind of like we're setting the impulse when we spawn it, we're going to set the agent impulse to a vector 2.0. And then we're going to set the velocity of these things to 0 also immediately. And just in case, we're going to set the friction to 1. If it has the player, we can remove the player. This actually is going to do this check internally, so we don't need the if check here. And we can also do a remove move to player. So if we have this component, remove it. So set the friction. This will make it sure it comes to complete stop, and then we'll make sure that this velocity actually hits 0. The way I do it in a different system is that I have the enemy animate their death, and when they animate their death, I set their velocity to 0, and then instead of waiting for their velocity to reach 0, I wait for the animation to end before I clean them up. For this demo's purposes, I don't think I need to go into that death because we don't have a death animation, for example. So I think I'm just going to make this as simple as possible and basically just call the set collider and destroy. Now it's going to complain because we made this a coroutine enumerator and it doesn't need to be a coroutine enumerator. So we're just going to pop up, do that, and we can save this for later. So let's see. Okay, so the enemies are instantly cleaning up as soon as they touch us, and so do we. This little fella, he keeps skating because his impulse and everything is set. So again, there's a little bit more cleanup that we can do for that, including the fact that we are still spawning. This while true doesn't make a lot of sense to just keep going even though we're dead. While world dot get unique. Try get unique entity of player component. No. The red and the white being faster is correct. So that impulse stuff is working. So that's cool. I just noticed that. The things still skate around. These things are still moving. So that's a problem. Why would this be coming back as correct? Try get unique entity. Oh, cached unique context. That's probably why. So it has a cached value for, say, the player in order to save some processing time. So this actually, and this entity is actually alive, which is interesting. We can't do the get because this will throw. Probably just need to find out what we can use instead of this try get unique. So maybe we do this. We wait for a frame. We get our player component, our player entity, our player, and then we do world.get entity player.entity ID, like that. And then say it's not equal null. Player may be null here, so we'll just do dot entity ID. So we always expect the player to be existing at the beginning, so we're just gonna get the player entity ID here. Play. Easy enemies to crash into. Now you'll notice the jank with the grid. Because the way we're doing it right now, it's not really set up to work with this kind of a grid. However, we did successfully stop this from spawning. So once we hit our limit, dodge them. We can't outchase the blue and the red. They're too fast. These guys keep floating, so we could fix that as well. We'll stop them from moving. If they no longer have a target, maybe we'll say instead of the player being not equals nulls, maybe we'll do, if the player is null, then do this for each entity. Maybe dot set velocity. Merrick's. Once the game is over. Oh, right, because yeah, we still need this this return. We kind of want them to be coming. There we go. They're moving, and they boom, stop moving. And then we throw up our end screen. You have died. There's so many points you got. Yay. Okay. That was a lot, but we learned so many things doing it. So many things to the point that I built an entirely other game while I was kind of learning this stuff and getting ready for this tutorial. So let's review. We have a camera that follows our player. We can perform actions over time with state machines, such as spawning enemies. Later, we can then spawn projectiles. We are creating new game asset categories, and we use the editor to create the JSON data that the system uses. So that's here in our enemies types. We have our lamp types, we have the lamp data, we have spawn type, we have the offsets, we have a whole bunch of stuff that we have in here, as much stuff as we want, as we need. We can even have some kind of Python script or some other thing to like create this JSON from an Excel, set it up manually, right? We can just plug it in and it'll work with our game. So there's actually a lot of utility in these JSONs. We created the player camera follow system. We created the state machine. We've created the related elements of the state machine, the data asset, the event, the manager component, the move to player component, and the move to player system, and track the player and chase the player until they die. What I could do, perhaps, as a final showcase, current spawn delay, multiplied by 0.98. There. A 2% decrease per spawn, that can't be too bad, right? We're gonna die pretty fast here, so what we should probably do is either slow the enemies down or buff our health. As you can see, the enemy speed is increasing very rapidly already. Let's go into the enemy types here. Let's make this super slow. Like 20, 40, 60. We can definitely outrun these guys now. And to tank us up even more, let's give us like 20 HP, double our HP. Okay, now let's see what we can get up to. Dodge the first guys that are static. We can remove those guys that are just statically in our world. Look how slow the white ones are. The red ones, they're a bit of a threat. They're keeping up, but we're fast. We're schmoving. Keep up. Oh, the spawns are getting faster and faster. I'm running out of room to dodge. There's some things I want to talk about regarding like the room borders and like why the enemies that spawn outside are like getting stuck and stuff. But I don't want to go over that in this video because I think that's going to make a lot more sense when we talk about tile sets and things. Oh, I'm going to trap myself. I'll go this way. No! Okay. Even though these all have colliders on them and they are, say, colliding with this terrain here, this tile map that already exists. Dodge. Okay. We can still get a lot of them on screen, and they actually collide with each other because they have solid hitboxes here. I wonder if we make them not solid hitboxes, if they will go through each other. Collider, solid. Check there. They do still get stuck outside the level when they have a hitbox. And this does have to do with the way we set them up. We did make them agents. We didn't just make them sprites that were manually moving and controlling. So the agent system has a lot of things that it kind of checks and relates to, all that sort of stuff. We're getting a lot of enemies on screen. Okay. I still can't survive very long. Like, that's why we need projectiles. We will be able to fight back eventually. For now, thanks for murdering with me. Is that gonna be my catch? We'll see what people think. Okay. See you next time. Bye.